Hello everyone, welcome back to this another video session. I am Chetan Rajoria from the Department of Mechanical Engineering, ABES Engineering College, Ghaziabad. And in this session, we will discuss another problem based on free body diagrams, that is FBDs and concurrent force system. So let us see what is the problem. Okay, students, this is the problem which we are going to discuss here. Two smooth rollers are placed between a frictionless inclined surface and a frictionless vertical wall as shown in the figure. Find the reactions at all the points of contact. Both rollers are of equal size. The weights of these two rollers has been given here. W1 is 250 newtons and W2 is 200 newtons. This is the first roller having the weight of 250 newtons and the second roller is having weight of 200 newtons. This is the vertical wall, this is the inclined plane, and these two rollers are placed between these two surfaces. The inclination angle of this plane surface is 15 degrees given in the question. So we need to calculate the reactions at these points A, B, C, and D. A is the point of contact between the first roller and the vertical wall. B is the point of contact between the first roller and the inclined plane. C is the point of contact between the second roller and the inclined plane. And D is the mutual point of contact between these two rollers. So let's proceed. First of all, we will decide which roller is to be considered first. We will consider that roller in which we are going to get lesser number of unknown forces. So in the first roller, we will observe two unknown forces only, the reaction at point D and reaction at point C. But if we observe or if we consider the first roller first, in that case, we will observe three unknown forces at point A, D, and B. So actually, because this is a concurrent force system at each and every roller, so in a concurrent force system, we are actually having only two equations to solve. So we cannot solve any problem in which there are more than two unknown variables because we are having only two equations and mathematically it is impossible to find the solution. So we will consider the second roller first. So let us draw the free body diagram of the second roller. Suppose this is the second roller. And let's draw the free body diagram. First of all, we will show the weight of this roller. The weight of this roller is 200 newtons. Okay. Now let's draw the reaction at point C. Point C will be somewhere here, and the reaction will be going like this. According to the principle of transmissibility, we can show this reaction at this point also. We can transfer a force anywhere along its line of action within the limits of that object. So we can show the reaction at point C at the center of this roller, and this reaction will be represented as RC. Now let's show the reaction at point D. The reaction at point D will be inclined upward at an angle of 15 degrees because the size of these two rollers are same. Therefore, the mutual reaction between these two rollers will be parallel to this plane surface. Okay. So the inclination of the reaction at point D will be same angle 15 degrees. So let us show it. And once again, we are using the principle of transmissibility. We are going to show this reaction at the center of this roller. So this is somewhere here. This is the location of point D. but we are showing the reaction here. And suppose this is RB. The inclination of this reaction is 15 degree, and the inclination of this reaction, RC, this RC is actually perpendicular to this plane surface, inclined plane surface. Okay, this is RC. I've shown here also. So the inclination of this reaction will be 15 degree with vertical. Okay, because the inclination angle here is 15 degrees. So according to the geometry of this figure, we can prove that the inclination of the reaction on this plane surface will be 15 degree with the vertical. So 15 degree with vertical means 75 degrees with the horizontal. We can show the angle like this. Now we can solve for RC and RD using two methods. The first one is Lami's theorem, and second one is by resolving the forces into the vertical and horizontal direction. Lami's theorem application will be much easier here. So let's apply Lami's theorem. So according to Lami's theorem, before applying Lami's theorem, we need to calculate the intermediate angles between any two consecutive forces. So clearly this angle is 75, this angle is 15. Therefore, this angle will be 90 degrees. The angle between RD and 200 Newton, this complete angle will be 90 plus 15, that is 105 degrees. And angle between RC and 200 Newton will be 90 plus 75, that is 165 degrees. Okay, so let's apply Lami's theorem. 200 upon sine the angle between the remaining two forces, RC and RD, 90. What is the Lami's theorem? Let's recall. The ratio of any force and the sine of the angle between the opposite forces or opposite, you can say, vectors, the ratio remains constant. So we are using the same expression here. So 200 upon sine 90 is equal to RD upon, we will take the angle between these two forces, opposite or remaining two forces, RC and 200. This is 165. So sine 165 degrees is equal to RC upon, what is the angle between the remaining two forces, RD and 200? It is 105 degrees. Sine of 105 degrees. So this is the expression of which is known as Lami's theorem. Sine 90 is 1. So we can write directly RD is equal to 200 sine 165 degrees. 200 sine 165 degrees, and its value is coming to be 51.760. 51.76 newtons. Okay, that is the first answer. Value of RC can be written as 200 sine 105 degrees. 200 sine 105 degrees. And this value is coming to be 193.185 degrees. 193.185 newtons, sorry. So this is the second answer. So we have calculated the value of RD and RC using Lami's theorem. If we wish to calculate the same values using the principle of resolution of forces, we need to write two equations. Okay. And okay, let's write the equations. Minus RC cos 75 degrees, the horizontal component of this force RC, which is acting towards left, plus RD cos 15 degrees. Only these two forces are having the horizontal components, and there will be no horizontal component of this force 200 Newton. So the summation of these two should be equal to 0. This is the first equation. And let's write the second equation for the vertical forces. The vertical component of RC and RD both will act in the vertically upward direction, and the opposite force is only this one, 200 newtons. So let's write the second equation. RC sine 75 degrees plus RD sine 15 degree minus 200 equals to 0. So this is the second equation. So we can get the same results which we achieved earlier using Lami's theorem. We can achieve the same results using these two equations also, okay, algebraically. Now let's move ahead. Now we have calculated the value of RD and RC. We will use these two values for the calculation of the remaining forces RA and RB. So let's draw the free body diagram of this first roller now, roller number 1. So this is the first roller. The reaction from point A will act in the horizontal direction because the wall is vertical, therefore the reaction will be horizontal. So I'm going to show this reaction at the center of the roller, just for the ease of understanding. So this is RA, which is actually unknown right now. The reaction at point B, this will act perpendicular to this inclined surface like this. Okay, the previous force was acting like this, and now this reaction RB is acting like this, perpendicular to the inclined plane surface. So once again, it will act towards the center. I'm going to show this force here. This is RB. The reaction from the second roller on the first roller will act in the opposite direction. Previously, the force was shown 15 degrees upward, RD, because this was the force which was acting from the first roller onto the second roller. Now we are discussing the free body diagram of the first roller. Therefore, the force because of the second roller on the first roller will be in the opposite direction. Angle will be same, but the direction will be different, just opposite. So this is the reaction. Sorry. This is the reaction. RD acting in the opposite direction as discussed earlier. Angle is same, 15 degrees. And the last force will be the weight of this roller. What is the weight of this roller? The weight of this roller, roller number 1, is 250 newtons. So it's 250 newtons acting vertically downward. So this is the free body diagram of the first roller. Okay, this angle is 75 degrees as discussed earlier. So let us write the equilibrium equations by resolving these four forces into the horizontal and vertical direction. So let's write the equilibrium equations. minus RB cos 75. Okay. In the left hand side direction, the component of this force minus RD cos 15, the horizontal component of this force. Okay. It is also acting in the left hand side direction, plus RA, which is acting in the right hand side direction, is equal to 0, because there will be no horizontal component of this force because it's purely vertical. There will be no horizontal component. Now let's write another equation for vertical forces. This is the equation of horizontal forces. I can write like this: sigma fx equals to 0. Now I'm going to write sigma fy equal to 0. Okay. So what will be the equation? RB sine 75 degrees acting in vertically upward direction, therefore positive, minus RD sine 15 degree acting in vertically downward direction, therefore negative, minus 250 because it's pure vertical force acting downwards, and we will not consider RA because it's purely horizontal. So these are the only three forces which will be considered for vertical forces equation. So RB sine 75 minus RD sine 15 minus 250 equals to 0. So this is the second equation, and we can solve these two equations mathematically, and we are going to get the following results, because uh, in these two equations RD is actually unknown. Sorry, RD is known value. We already calculated this force RD previously. So there will be only two unknown forces, RB and RA. And we can solve these two forces using these two equations mathematically. So these are the final results for you. RB is equal to 272.68 degrees, 68 newtons, sorry, 272.68 newtons, and RA is equal to 120.81 newtons. So this is the third answer, and this is the fourth answer. So in this way, we calculated all the four support reactions or at various points of contact.